Welcome. We're going to do 6.4 nth root. First thing we're going to look at is a new symbol here on the outside of the radical. That is called our index. And the goal is to take whatever is under the radical, which is the radicand, and we want to simplify. By simplifying, we talk about looking at primes, breaking it down into primes. And then after we find the primes, we group those numbers, variables, whatever it may be, according to whatever your index is. So let's take a look at our slide here. Here's our first example, the cube root of negative 432. And what's going to happen is I know 432 ends in a 2, so it's divisible by 2. So I'm going to break it down. 2 times 216. And the 216 also breaks down into 2 times 108. And then 108 breaks down into 2 times 54. And I'm going to go ahead and cross out the numbers I've already broken down into primes. 54 is 2 times 27. And then finally 27 is 3 times 3 times 3 from the cube lesson that we had. So now what I want to do is I want to go ahead and group them according to our index, and our index is 3 up there. So the first one I see is this group of 3 2s, and then I see a group of 3s down here, 3 3s. So that 2 with the 3 comes out, and everything's timesing, getting products here. The 2 is left behind because it doesn't have a group around it. There's a negative under the radical. So that negative under the radical, because you're dealing with an odd index, is possible to have a negative answer. So finally, negative 6 radical 2 is our final answer. Let's take a look at the next example here. Next example, we have the fifth root of 243. So 243 is 3 times 81. The 81 breaks down into 9 times 9. The 9 breaks down into 3 times 3. My dogs want to come inside. The 9s have been broken down. So I see a group right there. There's 5 of them. So that 3 is going to come out. Let's take a look at our variables. A, there are 10 of them. Well, if I can write all 10 A's, yeah, and then see how many I can group into 5s. Well, I know because of multiplication, there's 2 groups in that 10 of 5s. So 2 groups come out. The B's, I have 7 B's. Well, if I group them, only 1 group come out. And then there are 2 left over. So let's see. That one, 1, 2, 3, 4, 5, 6, 7. So here's my 5 B's according to the index. So that comes out as a 1 group. And then there's 2 left over. So let me clean this up here. We have a 3, A to the second, just a lonely B, and then we have our index of 5, or the fifth root of b squared. So that one is my final answer. Moving on to the next one. We have a negative on the outside, so I'm going to bring that negative down as part of my answer. And then I have no index visible. Well, that's understood to be a 2 there. Well, 2 goes into 12 6 times, so there's 6 of these guys that come out evenly. And then, of course, bring down that negative. And that one's my answer. Okay, let's see what we have. Next example here. We have a negative under an even index. Well, we already did that lesson. This is just a review. So we're going to take the 5, because square root of 25 is 5. The negative becomes an I because we have an even index. So you have an I there. And then x to the 5th, well, let's see here. You have 2 goes into 5 twice, and you have 1 remainder. Well, that means that there are 2 x's that come out, 2 groups, and an x is left behind. Another way to look at it, you have 1, 2, 3, 4, 5 x's under the radical. You want to group them by 2's. So see, there's only 2 groups. That's where that comes in. And then there's just a lonely x, and that's that lonely x right there. Okay. Moving on to the next and last example. If an even index has a variable answer that has an odd exponent, then use absolute values to ensure that you always get a positive value, because we don't want to deal with imaginary numbers since we have variables. That would be kind of weird. With numbers, no problem. We can have imaginary, but with variables, So let's take a look at this one here. So on this one, we have my index is 4. There's only, and when I break down this x, there's only xx. Well, that's not going to get into any groups of 4. With the y's, I end up with y, 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 and a y. So there's a group. So that's going to come out. And then the 4th root of x squared, since it didn't have ability to get into groups of 4, stays. I'm going to go ahead and emphasize once again what I typed up there. This exponent has this variable has an odd exponent, but it came from an even index of a 4. Even index. Odd variable and exponents there. So then I have to make sure I put absolute values around that, so that I always get a positive value. Because y, I can substitute a negative number in there. I can substitute y to be a -5. Well, I don't want a -5 if I'm pulling it out of an even index. It has to be positive. I'm not dealing with imaginary at that point with variables. Let's look at another example here. With this other example, I have 64. So I'm going to break down 64 into 2 and 32. 2 and 16 is that breaks down to 32. Then I'm going to do 4 and 4, and then 4 breaks down into 2, 2, 2, 2. All right. So there I have 1, 2, 4. Oh, I have 6. So I have 6 groups right there with the 2's. So that's going to come out. My x squared minus 3 has a quantity to the 18th power. Well, 6 goes into 18 3 times. So, to the 3rd power. And let me put this here, sorry, to the 3rd power. Because it's odd, coming from an even index, absolute value it. So there's the answer to that. Let me clean this up a little bit here so you don't get too mixed up with that stuff. So there's the answer to that problem. And that was a 3, because 6 goes into 18 3 times. So like I said, let me clean this up, or not. That's an ugly 3. All right, guys. Well, any questions, please ask me tomorrow in class. I will answer all of them. Have a great day.